Good afternoon, everybody in Econ land. Welcome to another asynchronous lecture in Econ 100B Intermediate Microeconomics. I apologize again for missing class, but today I'm going to go over the rest of Chapter 8, and I'm going to go spend some time. It sounds like some people still have questions about the residual demand and individual firm elasticity problem. So I'll run through the slides and give us a little bit of a review of what we've done so far, and then talk more about that. And then we'll wrap up the chapter talking about the short run and long run equilibria for firms in a competitive market. Sound good? All right, let's go. Okay. Let's get started. So we are looking at Chapter 8 this week, talking about firms in competition in competitive markets, right? Perfectly competitive markets. And so really what we're talking about is our ideal market structure. We're looking at what perfect competition is, how firms behave, how they select profit maximizing quantities, and how they behave in the short run in competitive markets and in the long run. And economists love to study perfectly competitive or competitive models because they're an important benchmark against which to compare other market structures. Many markets are similar to competitive market structures, and perfectly competitive markets are welfare maximizing. And so they're sort of our goal in terms of where we want other markets that are less competitive to be. And so we want to remember that this is a market structure, and it's defined mainly by the number of firms, the ease of entry and exit, and the level of differentiability of the goods in the market. And all of these things lead to firms being price takers, which means that they basically face a horizontal demand curve. And that's because, again, there are many buyers and sellers. The products are homogeneous. They're all the same. There's full or perfect information. There is free entry and exit, and there are negligible transaction costs. And so it's just the idea of a market working perfectly, right? There are, of course, deviations from perfect competition, and we can talk about that. And this gets to the next thing we wanted to talk about, which was this. I wanted to review the horizontal demand curve that we expect an individual firm to face. And so again, here we have our 5 characteristics of perfectly competitive markets: many buyers and sellers, identical products, full information, negligible transaction costs, and free entry and exit. When we are talking about perfect competition, we recognize that most markets aren't truly perfectly competitive, but many markets are competitive enough that we can model them in the same way we would market a perfectly competitive market. There might be some adjustment times and that kind of thing. And we'll get to a little bit more nuanced view of this when we start to look at short run and long run equilibria. But where we got a little bit stuck last time was, and people had some questions, was this idea of a residual demand curve and individual firm versus market price elasticity of demand. So we have this example here of a market that sells metal chairs. So this is the entire market here for metal chairs with some upward sloping supply curve and some downward sloping demand curve. And that makes sense. That's a competitive market, right? We have supply and demand, downward sloping demand and upward sloping supply. We want to think, though, about how an individual firm in that larger market feels. Each individual firm out of thousands of other firms does not face that downward sloping demand curve, right? They are one of hundreds of other firms, or at least tens of other firms, right? There are lots of other firms out there. And so they can't behave like a monopolist because of that features of perfect competition, because there are many firms, because the goods are largely the same, because there's perfect information, because new firms can enter and exit at any time, and because there aren't very high transaction costs. If this firm here, firm A, decides to raise the price of their metal chair from say $66, where the residual demand is 0, to $67, they're going to face a demand of 0, right? They can't just raise prices. They can try to lower prices, but even if they lower prices, other firms are going to step in. And to measure that, we can look at elasticities. Remember, elasticity is responsiveness to change. Price elasticity of demand is how responsive demand is to a change in price. price elasticity of supply is how responsive supply is to a change in price. And so what we looked at to kind of prove that even if individual firms don't face a perfectly horizontal demand curve, they face an almost horizontal demand curve, we looked at the elasticity of demand for a single firm I. And so that's this example here where we say, okay, one firm out of hundreds or 100 identical firms has its own individual price elasticity of demand, the effect that it will have if it raises or lowers prices. So think about it being one of the hundreds of taco places in Sacramento or one of the thousands of gas stations in Sacramento. There's a price elasticity of demand for the market, and that's this E. And that's for all the gas stations in the market of Sacramento. But there's also the price elasticity of demand for a single gas station on a single corner in town. If they change their prices, they're going to face a different effect than if all of the firms change their prices at the same time. That's one of the kind of functions of why competitive markets behave the way they do. And so to find out what the elasticity of demand for firm I is, we can take the number of firms in the market, the price elasticity of demand for the whole market, and the price elasticity of supply for the whole market, or all the other firms in the market, and that will give us that number. And so let's go ahead and look at that example. All right, so what we were talking about as the example of looking at the difference between market elasticity and firm elasticity was this example here, where we were given this equation where we can find the price elasticity of demand for one specific firm by looking at the number of firms in the market, the price elasticity of demand for the whole market, and the price elasticity of supply for all the other firms in the market. And so really when you think about it, this equation is pretty straightforward, right? The math is fairly simple and the equation makes sense, right? Because we're just looking at the number of firms in the market and the price elasticity of demand in the market, and then all the other firms supplying and their price elasticity of supply. And between those two figures, we can find the price elasticity of demand for that one firm in the market. So in the example we were given, can you guys see that kind of? I'm trying to get the lighting right. Market price elasticity of demand is negative 1.1. So that means that a percent change in quantity demanded divided by a percent change in price for the whole market is going to have that negative 1.1 effect. So for example, if we saw the market increase prices by 10%, we can use that price elasticity of demand 1.1 negative is equal to 0.1 and then find that percent change in quantity demanded by taking negative 1.1 times 0.01 or 0.1 to get the percent change in quantity demanded, which is going to be 11%. Does that kind of make sense? Hopefully it does, right? Because this is elasticities. We've talked about elasticities. You should have encountered them in Econ 1B and in other econ classes, so they shouldn't be so unfamiliar. I know they're kind of a complicated concept to get a hold of, but we're looking at the percent change in quantity demanded divided by the percent change in price, and that gives us that price elasticity of demand for the whole market. In this case, that price elasticity of demand of negative 1.1 that says that there's almost a one-to-one relationship between the changes in price and the changes in quantity demanded. Cool? The price elasticity of supply for the market is looking at all the other firms' abilities to change quantity supplied based on a change in price. And then what we're finding here, EI, is the price elasticity of demand, not for the whole market, but just for one firm out of the whole market. And so if we think about, say, all the gas stations in Sacramento, they might have a price elasticity of a demand of -1.1. But if one gas station on one street corner decides to change their prices, they would face a different price elasticity of demand than everyone else, right? Imagine you go up there, there's lots of street corners around where there's one or two gas stations within a block of each other. If one of them raises their price by 10%, how much do you think their quantity demanded is going to go down? If no one else changes their prices, it's going to change a lot, right? They can't be the only one changing their prices. And so that's what we're looking at is, what if one out of, say, 78 firms changes their price? What's that going to have? And what kind of effect is that going to have on quantity demanded? So let's go through and calculate it. So we get EI. Let's try a better color. The price elasticity of demand of firm I is equal to 78 times -1.1 minus 78 minus 1 times 3.1, which gives us, let me get my numbers out here, -85.8 minus 77 times 3.1, or -85.8 minus 238.7, which gives us a individual firm price elasticity of demand of -324.5. So that tells us that this firm has a very, very high price elasticity of demand. Elasticities, we usually talk about them being between 0 and 1, and 1 and maybe 3 or 4, maybe 5 or 6. 300, we usually talk about single-digit elasticities. This is a massive elasticity. And that's the point. The point here is an individual firm faces a lot more elasticity in response to their changes in price than the entire market does. If the entire market changed its price by 10%, they would see a change in quantity demanded of 11%, right? Let's put it right here. If they change their price, if they increase their price by 10%, they'd see an 11% decrease in quantity demanded. For an individual firm, their elasticity is -324.5. So if they change their price by 10%, oops, there we go. We can solve for the effect on quantity demanded. So if this individual firm changes their price by 10%, oops, come here, times 0.1, they would see a an increase in, or a decrease in quantity demanded of 324%. Does that make sense? So the market changes price by 10%, 0.1. They're going to see quantity demanded decrease by 0.11. This individual firm changes its price by 10%. They see their, oops, let's do it that way. They see their quantity demanded change by 324%. Does that kind of make sense? Or let's put it this way. Let's put it in percentages, or in decimals. 0.1 and 32.45, 0.01, 0.11, and 0.1. Do you see the difference here? Do you see the difference between the individual firm's price elasticity of demand and the market's price elasticity of demand. The firm is a member of the market, but when we compare the individual firm to the demand for the whole market and the ability of the rest of the firms to supply those goods, if they raise their prices, other firms are going to jump in and say, oh, we are happy to supply that good at a lower price. And that's why we can talk about, in a competitive market, a horizontal demand curve, right? So if we think back to this example, you don't know this, but I had technical difficulties. It took me a half hour to get this together. Okay. So the market demand behaves totally normally, as we would expect a market for any competitive good to behave. So let's say maybe this is our price. I think the example that we were given was something like $66. And that gave us, what was the equilibrium for the metal share market? The equilibrium quantity was 500 units, 500 shares, right? The individual firm, however, is going to see something a lot flatter, maybe something like that demand curve, where, yes, there is a bit of a slope, but really functionally, if they raise prices by, say, let's say they're supplying 10 shares to the market, if they raise prices from $66 to, say, $66.50, their demand goes to zero. If they lower prices from $66 to, say, $67, their quantity demanded goes up to, say, 30. The book had another example of this, but the idea here is what we've proven with that individual firm price elasticity of demand. The idea is, even though the market faces a downward sloping, regular, fairly elastic demand curve, or unit elastic demand curve, we're going to expect maybe not perfectly elastic demand, but elastic enough for our purposes. This is close enough to flat, close enough to an elasticity of infinity, where changing a price by 1 penny results in an infinite change in quantity demanded. It's close enough to that we can model it that way. And that was the whole point of that exercise. Hopefully that helps it make sense. If it doesn't, let me know. We'll talk about it some more. But that's all that this was. Okay? So let's go back to the slides. Okay. So if we go back to where we were, sorry, let me get that in here. So this was the example, right? And the whole point was to explain why we can rationalize in a market with a downward sloping demand curve an almost or effectively horizontal demand curve for an individual firm in competitive markets. That's the whole point, right? In perfectly competitive markets, we're going to say that marginal revenue and demand and price are horizontal because these firms are price takers, and we can prove that with that individual firm demand elasticity. And that's the whole point of this exercise. And if you want, you can go into the book and take another look at it. It's not the most important thing in this chapter. It's just a validation of what we've said. So now we can talk about profit maximization, which is really important, right? The goal for any firm is to maximize profit. We want to remember we're talking about economic profit, which means we're talking about economic cost, which means we are always talking about opportunity costs, including explicit and implicit costs. We can think about the two decisions each firm has to make. The output decision, what is the profit maximizing, loss minimizing quantity to produce, and then whether they should produce or not with respect to whether they might minimize losses by shutting down. So we have the output decision, what Q to produce, and the shutdown decision, whether or not to produce. We can think about marginal revenue being the derivative of the change in revenue given a change in output. Or we can think about marginal profit being a function of quantity and equal to marginal revenue at a given quantity divided by minus marginal cost at a given quantity. So our marginal profit at some Q is equal to our marginal revenue at that Q minus our marginal cost. So this gets back to this idea of this maximizing point, this profit maximizing point. So if profit is a function of the quantity we produce, we will see that profits rise as we increase production and then fall as we continue to increase production past the point of efficiency. And that's because of the shape of those cost curves, right? The shape of the average cost and average variable cost and marginal cost curves, because of the diminishing marginal productivity of our inputs. So where profit is maximized, we're going to see as the slope increases, profits are positive, the change in profits are positive. And then at the point where profits are maximized, change in profits is zero. That's our Q star. That is the profit maximizing quantity. And then the downward slope of this curve, we see the change in profits is negative. We're actually losing profits as we produce more. So the shutdown rule says that firms only shut down if they can reduce costs by doing so. There are basically three rules. If we go back to this idea of, we talked about this last time, this idea of the output rules. We want to set a quantity where profits are maximized. We want to set a quantity where marginal profit is equal to zero, that peak profit point, right? Here, marginal profit is equal to zero. Here is where profits are maximized. And it's also going to be there that marginal revenue is equal to marginal cost. When we think about the shutdown rule, we want to remember in the short run, fixed costs can't be changed. So even in this example where revenue is $2,000 and variable cost is $1,000 and fixed costs are $3,000, should we stay in business? Yes, absolutely. Those fixed costs are sunk. We cannot change them. We can minimize losses by still staying in business because we have to pay those $3,000 fixed costs no matter what. So another way to think of it, and I know I did this last time, is to say, okay, if we have to pay fixed costs no matter what, then the shutdown profit is going to be $0 in revenue minus $3,000 in fixed costs. The production profit is going to be $2,000 in revenue minus $4,000 in fixed and variable costs, right? So this is our shutdown revenue and our production revenue. This is fixed costs, and this is variable cost plus fixed cost. And we can see negative $3,000 is greater than negative $2,000. So the loss minimizing decision is to not shut down. So the shutdown rule says that firms only shut down if revenue is less than avoidable cost. We'll see that rule, that type of the rule, or these two rules are applicable to both the short run and the long run. It's just a matter of whether or not we consider those fixed costs sunk. So firms shut down only if it reduces losses. Firms shut down only if revenue loss is less than avoidable costs. The next part we wanted to talk about was the idea of the short run output decision, where we're going to see, we want to remember that marginal revenue is equal to price because of that horizontal demand curve, because of a competitive market. That means that a profit maximizing firm is going to choose to produce where marginal cost is equal to marginal revenue. Since marginal revenue is equal to price, we're going to see that profit maximizing competitive firm produce at marginal cost equal to marginal revenue. So let's take a look at the cost curves of a competitive firm. So we have our average cost curve here. We have our marginal revenue curve here. Again, it's that horizontal line because of what we talked about. Because this firm is in a competitive market, it's a price taker. So it takes that market price of $8 in this case as a given. We need marginal cost to see how this firm is going to produce. Given this marginal cost curve, which crosses average cost at its minimum, we can see this firm is going to produce at 284 units. That's the equilibrium point, where marginal cost is equal to marginal revenue. This should be somewhat of a review. So profit is maximized, where marginal revenue is equal to marginal cost. That's at Q equal to 284. At that quantity, average cost is $6.85. So we can use that to help us calculate profits for that firm and prove that it's the maximum profit point. So if we look at this area, we can see that the revenue per unit is $8 and the cost per unit is $6.50. So that means the marginal profit, or the profit per unit, the average profit, is going to be $1.50 for every unit produced, or 150 times 284,000 metric tons of lime. Does that kind of make sense? Hopefully. We looked at this last time. Hopefully it's starting to feel familiar. If this is how much I can sell lime, in this case for, and this is how much it costs me to produce it, $6.50, and I managed to sell 284, then that means that's going to be my total profit, right? In this case, profit at a given quantity is equal to revenue, which is price times quantity minus the cost times of a quantity, right? So we can also add in that profit curve here that shows that profits are falling when our profits are below zero when average cost is too high. As we get to the point where average costs are falling, we get to the minimum average cost point where marginal cost is equal to average cost, that $6 price at 140 units. We still see we're on the upward sloping portion of that profit curve. Profits are maximized at that quantity of 284 units, where the cost or the revenue, the profits are $426,000, and the change in profit is zero. Make sense? The firm shuts down only if it can reduce losses by doing so. So to do that, what we want to look at is we want to look at the revenue given at a given quantity and compare it to the price at that quantity and the variable cost at that quantity. So if we break that down a little bit, we can say, okay, I think you guys can see this over here. If revenue at some Q is equal to price at that quantity, and the shutdown rule says that we want the revenue to be greater than the variable cost at that quantity. If we take the average revenue at those points, what we see is if we want to take the averages, we get PQ divided by Q is P, and VQ or VCQ divided by Q is average variable cost. Does that kind of make sense? If revenue is price times quantity and variable cost times quantity, if we want to find our shutdown rule to prove that the revenue is loss minimizing, we can just look at price and average variable cost. Any price greater than average variable cost is going to minimize losses. Any price below average variable cost is going to be a shutdown worthy price. It's no longer going to be a loss minimizing choice to produce. So a competitive firm shuts down if the market price is less than the short run average variable cost. And that makes sense because in the short run, we are not worrying about our fixed costs. We're only worrying about our avoidable variable costs. The fixed costs are sunk. So short run shutdown decision is a function of price and average variable cost. We shut down if price is below average variable cost. So here's an example where we can look at some different curves. We've got a marginal revenue curve here at a price of $5.50. We have average variable cost here, and we can see that average variable cost is minimized at a quantity of 50, and we've got our marginal cost curve here. If we solve this like we solve every firm problem, we want to start with the profit maximizing production point. That's going to be marginal revenue equal to marginal cost. That's our equilibrium, E right there. Quantity of 100, price of 550. Here we can see at that quantity, average cost is above the price and average variable cost is below that price, right? if we click in here, we see that producing is going to make us a revenue of $550 because we're going to sell and produce 100 units at $5.50 each, right? So 5.5 times 100 gives us 550. I'm not going to totally check that math just to make sure because I hate doing math impromptu. Yeah, $550 in revenue. So we'll have, in this case, let's put it up here. The revenue at our given quantity is $550. Our average cost per unit is higher than that, right? If you look at the graph at a quantity of 100, it costs us $6.12 to produce each unit. So the cost at that level is $612. So we are taking losses, but some of those costs are fixed, meaning they're unavoidable, and that makes them sunk. We have to pay them no matter what. So we look at average variable cost, and the average variable cost at that level, the variable costs as a function of that quantity of 100 are $514. So if we think about the losses we would take if we shut down versus if we stay in business, producing is going to give us, the sort of profit associated with producing is going to give us 550 minus 612, right? The profit associated with shutting down is going to give us $0, and we're going to have to make up the difference between average and variable cost, which is about $100. There's still going to be a loss. So if we shut down, we still have to pay those fixed costs, and that's going to mean that we're still going to take losses. The losses are going to be greater than the losses we would take if we stayed in business. On the other hand, if we go back here and we look at, say, a point A, where we're crossing the average variable cost, anything below point A, that is a shutdown point, right? That's a point where, in the short run, losses are minimized by shutting down. Does that make sense? Hopefully. It gets all back to that idea that fixed costs are sunk. You have to pay them no matter what. It's your rent, it's your mortgage, it's something that you can't change in the short run. And so we don't consider it. We only look at those average variable costs when determining whether to shut down or not. So there's a weird example here in the book. Real quick, before we go back, I want to just give you guys the takeaway. So basically what we're looking at on this marginal cost curve are 3 different subsets of firm choice. For any market price above average cost, from point B on, the firm is going to operate. For any point between average variable cost and average cost, when the market price is somewhere between point A and point B, the firm is still going to minimize losses by producing. It's only for the points where price is below minimum average variable cost, below point A, that we are going to see the firm shut down to minimize losses. Does that make sense? One way I like to look at that is to graph it and say, okay, if I've got my curves here, lowercase q for my individual firm, and I've got average cost curve and an average variable cost curve. Where's my purple pen? There it is. And my marginal cost curve. I will see my firm produce anywhere from here on. This part is the shutdown area. I know that's really hard to see, so let's write it again in black to confirm it. Anything from here on is where firms will shut down to minimize losses. Okay? Cool. So here's a weird example. This is solved problem 8.3 from the textbook. It's in the slides too, so I thought we would talk about it. It's a little bit weird, but it's basically saying, assume you're a competitive firm and your bookkeeper is reviewing the books and finds that the firm spent twice as much on the plant, which is a fixed cost, than the firm's manager previously thought. Part A says, or part one says, should the manager change the output level because of this new information? And part two says, how does this affect profit? So think about that for a second. We're talking about changing a fixed cost, doubling a fixed cost. An accountant or a bookkeeper would say that's a really, really big deal. But in the short run, firms' decisions about what quantity to produce and whether or not to shut down or not are not affected by fixed costs, especially past fixed costs. And so it's not going to change the profit maximizing quantity produced. It's not going to change the output level with this new information because it's not changing this average variable cost curve or this marginal cost curve. Remember, the marginal cost curve is a function of variable costs because the fixed costs are the same in the short run. Part two, how does this affect profits? Well, if it's just a change in historical payments and it doesn't affect true economic profit, it might affect short-run profits, but as long as the opportunity cost is unchanged, it's not going to affect economic profit, not true economic profit. So this is a really weird counterintuitive thing. This is why people don't like economists, because normally you'd say, wow, doubling our fixed cost is a big deal. But in the short run and in terms of economic profit, it's actually not a big deal, and it's not going to change the optimal output level. Hopefully that kind of makes sense. If it doesn't, don't get too bogged down with it. The point here is just to emphasize how little fixed costs matter in the short run, right? They matter so little that you could double them and it won't even affect your quantity produced or your profits. Okay? So, a change in fixed cost does not affect the firm's decision, and a change in how the bookkeeper measures fixed cost does not affect economic profit because economic profit is based on opportunity costs and value, not on historic payments. So that takes us to the next continuation of what we were just talking about here, which is a short-run firm supply curve. So if price falls below a firm's minimum average variable cost, it's going to shut down. If a firm is producing, it's going to produce at any point along the marginal cost curve where marginal revenue crosses it. So a competitive firm's short-run supply curve is actually its marginal cost curve above average variable cost. Oh my gosh, I already drew it. So really what I'm saying is, find a new pen, a firm's short-run supply curve looks like this. That's the short-run supply curve. That's a terrible graph, though, so let's look at a better graph. Here we have a profit-maximizing competitive firm. Their supply curve is this red marginal cost curve, but the supply stops right here at a price of $5. At that price, that's the point where average variable costs are minimized. A firm that is a profit-maximizing competitive firm would not produce below that level. So any price below $5, the quantity supplied is zero. Any price above $5, the quantity supplied is given by the marginal cost curve. So as the marginal revenue or price rises, the quantity supplied rises. Do you see how that works? That's why it's the supply curve. It tells us as prices rise what the quantity supplied is. So the marginal cost curve above the average variable cost curve is a firm's short-run supply curve. This is a big idea. You should have encountered it in 1B. It should feel somewhat familiar. I get that some of this stuff feels fuzzy, so that's why we're going over all of the most important stuff together. If you have questions about this, let me know. If you want to review a problem like this, let me know in the discussion threads or hit me up. But hopefully this makes sense. Hopefully you can see how this marginal cost curve, as we put different prices in, we get different quantities supplied. So at a price of $7, the new equilibrium here, E3, is going to mean that the firm produces 215 units. That's literally what a supply curve says, how quantity supplied changes when price changes. It's only below this price of $5 that it gets a little weird, and that's because this firm would shut down at any price below $5. Make sense? Hopefully? Hopefully. Okay, so the market supply curve, the firm supply curve is a function of, is that marginal cost curve, is exactly that marginal cost curve above the average variable cost curve. So in the short run, the maximum number of firms in any given market is fixed because new firms need time to enter the market. If all the firms in a competitive market are identical, we can just sum those supply curves to get the market supply curve. And actually, this is true for all market supply curves. We just sum the individual supply curves. And there's two examples of this we're going to look at. We're going to look at markets where the firm supply curves are identical and markets where they're not. So in the short run, as the number of firms grows very large, the market supply curve is going to tend to turn horizontal at that point of average variable cost. So the more identical firms producing in a given market at a given market price, the flatter or more elastic the short run market supply curve will be at that price. And that's kind of a lot to take in, but let's remember what we just said, right? That as we add more of these identical supply curves, we're going to see the sum of them get flatter and flatter. And if that's hard to visualize, take a look at the graph here, where we've got an individual marginal cost.
You're done with your work. That's enough.
I'm not done with my work, hon.
But it's enough.
Can you give me 5 more minutes? Please? Okay. So we have the short run supply curve for an individual firm based on their average variable cost curve. And here we have the supply curve for the market if there's only that one firm. If there are 2 firms, we sum those 2 firm supply curves and we get this S2 market supply curve. And you can see already how the steepness of that curve is reducing, is flattening. 3 firms with identical supply curves would flatten more to S3. 4 would be at S4. 5 firms would be at S5. And so as we add more identical supply curves, we get flatter and flatter, and we increase the price elasticity of supply of this market. So that's what this is showing us. In a competitive market where firms face identical cost curves, face identical individual firm supply curves, have identical marginal costs. Basically, imagine an industry where firms face identical variable costs. So maybe labor is very homogeneous. We're going to see each additional firm adding to that market supply, flatten that market supply, and increase the price elasticity of supply. Excuse me. So that's with identical supply curves, identical marginal cost curves. In the other case, we can have firms with different supply curves. So here we have firm 1 has this marginal cost curve, this supply curve. And so we can see their market demand. And then firm 2 here has a different higher marginal cost curve. And so when we have 2 different supply curves with different quantities, with different costs associated with them, we do the exact same thing. We sum them horizontally and we get a little bit of a different curve, right? In this case, we get a kinked supply curve where market supply is firm 1's supply curve from a quantity of 50 to a quantity of 140. at that price of 6, because firm 2, for whatever reason, faces a higher average variable cost curve, firm 2 enters the market at that price of 6, not at the price of 5. And so that's where we see that supply curve kink, and the quantity of 140 gets an additional supply of 25 units added to it. And then we get this flatter supply curve from S1 and S2 combining. Does that kind of make sense? I feel like it's a little weird, so I'm going to take a break and show you how I would graph it on the whiteboard and give you a sense of how we sum those up. Okay? Cool. Okay, so here we'll look at a market with 2 different marginal cost curves for the 2 firms in it. And obviously we can imagine a market with a larger number of firms than just 2, but this is a nice simple example. So we start with one supply curve that looks like this, and another supply curve that looks like this. So this is S1, or sorry, S2 and S1. Is that right? Yeah. Okay. And S1 starts at a price of $5 and a quantity of 50 units. S2 doesn't enter the market and start producing their 25 units until price hits $6. At that point, firm 1 is producing 100 or 140 units. And what happens is, if we're drawing the market demand curve, it's going to follow S1 up until the point where S2 enters the market. At this point, S2 enters the market at a price of $6, and what they're going to do then is contribute, right? They're going to sell their additional 25 units. So now the quantity supplied at that price of $6 isn't just 140 that S1 is providing. Firm 1 is providing 140 units. Firm 2 is providing another 25 units. That takes us to a quantity of 165. So the supply curve goes like that. Do you see? From that point on, we now have a much flatter supply curve, and that's that market supply and the short run, and that's a function of the 2 supply curves combined. And so we can go through and imagine some other price here, maybe $7 is up here, and that's what the graph shows. At which point, ooh, is that going to do it? That's not going to do it. I have to do it higher. Sorry. Let's see. I got to get it just right because I didn't draw my curves quite steep enough. Nope, still not high enough. Where's this going to be? Yeah, I didn't draw these steep enough. Sorry, guys. It's much cleaner on my notes. So let's say this is the price of $7. This firm would have produced 100 units. This firm would have produced 215 units. So then the market supply would have been $100 plus 215, or 315. Does that make sense? So what that shows us is, at price equal to $5, the market quantity is Q1 plus Q2, which is 0 plus 50. Or sorry, 50 plus 0. Keep mixing up which one's which. 50 plus 0, which is 50, right? And that's what we see in the market. $5, 50 produced. At a price of $6, the market quantity supplied is going to be Q1 of 25, or sorry, Q1 of 100. Sorry. Okay, do over. It's going to be, let's say Q2 plus Q1, right? It's going to be that 25 plus that 140. At a price of $7, firm 2 supplies 100 units. Firm 1 supplies 250 units, so the market supply is 315 units. Does that make a little more sense, hopefully? The idea is not different from what we talked about earlier in the first couple of chapters when we looked at market demand and market supply, summing those curves. Same exact thing here, okay? Cool. Okay. So here you can see a little bit the cleaner version, but that's exactly what I'm talking about. So at $5, firm 1 produces 50 units. At $6, firm 1 produces 140, and firm 2 produces an additional 25. That puts the market supply at 165. As the price goes up, the quantity supplied by both firms goes up, and the supply curve flattens as more firms enter the market. So you can see the steepness of the supply curve when just firm 1 is in, and then the flatter slope, which indicates a greater price elasticity of supply as more firms enter. And that means that the more firms that are in the market, the easier it is going to be for firms in general, for the market in general, to adjust to changes in price. Last graph we want to talk about is the short-run competitive equilibrium in the lime market. And the idea here is that if we have an average cost curve, firm supply curve, an average variable cost curve as we see, oops, sorry, too far, we can imagine that this market supply is going to be able to tolerate multiple equilibria depending on market demand. So basically any equilibrium between E1 and E2 is possible, or any equilibrium from E2 and beyond, depending on where the price falls, depending on where market demand lies. And we can always calculate the profits associated with that, or the losses associated with that, by looking at the cost curves and the marginal revenue, or the price, right? Hopefully this is familiar. Hopefully this makes sense now, right? So we've got this marginal cost curve that is the supply curve for every price above average variable cost. And the firm is going to produce those prices, and those prices are going to be a function of the demand in that market and this market supply. Okay? Cool. So the last section in the book is long-run competitive profit maximization. Firms in the long run are going to choose the quantity that maximizes profit using the exact same rules in the short run. A firm picks the quantity that maximizes long-run profit, and the difference between revenue and cost is that profit, right? Profit is still long-run revenue minus long-run cost. It operates where long-run marginal profit is 0 and where marginal revenue is equal to long-run marginal cost. So we're using all the same rules and ideas here. The difference is we're talking about the long run, which means we can consider fixed costs no longer sunk, and we're going to expect costs to be a little bit different. And this is something that we missed when we did the firm cost section because we didn't quite get to the end of the chapter. But the main idea here is that in the long run, A, all costs are variable, and B, the average cost curve and the average variable cost curve are identical, because now fixed costs are variable costs. So we're not going to see a variable cost curve or an average variable cost curve. We're just going to see that average cost curve and the marginal cost curve. They're the only relevant curves. All costs are variable now. We also expect costs to generally be lower per unit and on the margin in the long run for lots of reasons. We expect increases in technology. We expect learning by doing. The fact that the longer we do something, the better we get at it, the lower costs will be. And then also the greater flexibility provided by the long run means that we'll be able to adjust prices. And so there's no reason for short run costs to be lower than at long run costs. Whatever our costs are in the short run, the long run gives us greater flexibility to adjust those. And so those long run costs are going to necessarily be shorter. So Firms are going to choose the plant size that maximizes long-run profits. So after determining their optimal output level, it's going to maximize profit or minimize losses, and then decide whether to shut down or to produce. If the firm shuts down, its revenue it's going to be because its revenue is less than its avoidable or variable costs. In the long run, the firm is going to shut down if it would make an economic loss by operating, because all costs are variable. So there's no longer any sunk cost to consider. A firm's long-run supply curve is given by its long-run marginal cost curve along and above that minimum long-run average curve. So the rules are the same. The only difference is now we've combined average variable and average fixed costs. We've combined fixed costs and variable costs because there's no such thing as fixed or variable, right? So a firm can choose levels of capital and levels of labor in the long run. And so the long run supply curve might be different from the short run supply curve. And we're going to, again, expect the cost to be lower. So now let's look at long run and short run curves and compare them. So here we have a blue marginal revenue curve that's flat. And then we have our short run average cost and average variable cost curves, and our short run marginal cost curve, our short run supply curve. This is all the stuff we already talked about, right? If the firm produces at marginal revenue equal to marginal cost, that's going to be this quantity of 50. They're going to make profits this size of this rectangle A, which is going to be 35 minus 28. So that's $5, $6, $7 times 50 units. In the long run, we're going to see long-run average costs be flatter and more stretched out for those reasons we talked about, because they can choose the ideal optimal combination of labor and capital, because they're going to tend to have access to greater experience, greater technology. And so we're also going to see this marginal cost curve be further out because the cost of producing these units has gone down. They can produce more at a lower cost. However, a lot stays the same. We're going to see the firm still produces at marginal revenue equal to marginal cost. That's still the profit maximizing quantity. Only in this case, in the long run, instead of being 50 units, it's 110. The profits are going to tend to be greater because the costs are lower and the quantity produced is larger. And we're still going to see that that marginal cost curve is only the supply curve from that minimum average cost curve beyond. So from that price of $24 where marginal cost is equal to average cost, that's our supply curve from there on. Does that make sense? Let me know if you'd like to try and review that a little bit. It's not too dissimilar from the short run average cost curve, and we're not diving into the differences in detail. We're just talking about them generally. Generally, the short run curves are the short run costs are higher. Generally, the long run costs are lower. Generally, in the long run, we produce more at a lower cost more efficiently and enjoy higher profits. Explicitly, the profit maximizing quantity rule is the same. Marginal revenue equal to marginal cost, only produce above that minimum average cost curve. So, the competitive market supply curve is the horizontal sum of supply curves. Just like in the short run, it's the same in the long run. In the long run, firms can enter or exit the market, and so we can obtain a long-run market supply curve based on how many firms are in the market at each possible market price. And this is where we're going to get our sort of long-run equilibrium conditions. And this comes from this idea of firm entry and exit. Firms will have an incentive to enter the market if long-run profits are available. If we see someone out there making tons of money, we're going to say, hey, why don't we do that? We want to make money too. So we will see firms enter if profits are greater than zero in the long run, economic profits, right? So if long run economic profits are greater than zero, firms enter the market. On the other hand, if long run economic profits are less than zero, if firms are taking losses in the long run, they will exit the market. So firms will make that choice about entry or exit based on the long run economic profit. What that implies is the marginal firm, the firm trying to decide whether to stay in the market or not, is going to choose to enter or exit based on those long-run economic profits. The marginal firm will stay in the market and will reach a stable equilibrium when long-run economic profits equal zero. So firms in the market making zero long-run economic profit are indifferent between staying in the market and exiting, and that's going to give us a long-run equilibrium. There's an application here looking at solar firms in California. You can see firms entering, and then the number of firms entering falling, and the firms exiting rising and then falling. And the idea here is they're approaching an equilibrium, right? At first, there were 603 firms in California doing solar power in 2008. The number went up to 1,057, and now it's coming back down and approaching an equilibrium as the number of firms entering and exiting starts to fall. So we will expect the long run market supply curve to tend to be flat if firms face that free entry and exit, and if the unlimited number of firms entering and exiting face identical costs and constant input prices. So those are the constraints that we expect. And this gets back to that idea that we talked about before when we said, not this example, but the other example where we said, okay, as more firms enter the market, we'll see the supply curves get flatter, right, and flatter. The long run market supply curve will be flat if there's an unlimited number of firms with identical costs, input prices stay constant, and there's free entry and exit. There's an example here of vegetable oil firms. I think they say there's something like 8 firms is the long run equilibrium, but you can see here there are enough firms that would give it a long run market supply. The idea here is just that with perfectly competitive markets, with those conditions met of constant identical input costs, we can see that long run market supply stay flat. It's not always going to be true. The last couple of things about the last section of this chapter talks about the different variations. So if there's limited entry, the number of firms is going to be limited, and that's going to make the supply curve steeper. Sometimes the government can restrict the number of firms entering. There might be some scarce resource, or there might be some cost associated with entry. That's going to give you a steeper supply curve rather than a flatter supply curve. We can also see long-run market supply not be flat if firms have different cost functions. The example in the book is different countries producing cotton. They're going to have different costs associated with the productivity of the land, labor costs, that kind of thing. So that's going to keep it from being perfectly flat. It'll be flat for every country, but it'll still have an upward tilt. It's kind of the example in the book is a stair-step example. If input prices vary, then we might see a upward sloping market supply curve. And that's because we're going to see factor prices drive that supply curve upward in the long run. And they call that an increasing market or an increasing cost market. The last example is if there is, here's an example of the long run firm with an increasing cost market. So here we see costs rising, and as production goes up, we see the cost associated with producing go up. So when we go from producing Q1 to Q2, the costs go up. So maybe that makes sense in a certain sense, right? If I want to increase production of my legal services, I have to hire more lawyers. As I increase demand for that specific labor, I might raise the cost of that labor. And so producing a higher quantity is going to raise that cost. And so then we'll see a supply curve that is upward sloping, not flat. Last example is if there is a very, very large buyer. If there's a really large buyer in the market, we can think about a large importer relative to the world price. We're going to see the residual supply curve generate that upward sloping supply curve. And so you can see an example here where we have Japan's excess supply for, I think it's cotton again. Oh, it's textiles. But what we see is that the excess demand of a big buyer is going to drive up their individual supply curve because the residual supply curve is going to be different. So that's basically everything in the chapter. That that tells us basically how to treat firms in competitive markets. So that gives us a lot to deal with. So we talked about the output rule and the shutdown rule. We looked at average cost curves, average variable cost curves, marginal cost curves, marginal revenue. We talked about why we expect that flat or horizontal marginal revenue curve. Basically that, those firms in a competitive market are going to be price takers at every level and at every stage, right? They are one out of many. And what that looks like in the short run equilibrium and the long run equilibrium. So there are going to be homework problems that are live. I'm going to put together a practice or a participation problem for y'all. If there's something specific that you want to look at in the participation problem, let me know. I'm just finishing up putting it together and I'll get that for you tomorrow. And then look at the homework problems. Let me know what questions you have or what questions about this chapter that you have, and we'll get to it. Okay. Thank you, everyone. Have a beautiful, beautiful day. Be well. Happy week 10, and I'll see you next time.